Hey guys, welcome back. Today we're going to start our discussion of acids and bases, just generally talking about characteristics of each. A lot of you already know about what an acid and a base is or have had experience with it without even realizing it. For example, you could be using lemon juice or eating some sort of fruit. They're usually acidic. Lemon juice can be as acidic as having a pH value of 2.0, which is pretty low. And as for bases, if you ever use bleach for cleaning or on your clothes, that is an excellent example of a base. So we're going to talk about just like what properties acids and bases have, and then we'll get into the definition of why acids are acids and why bases are bases. Okay, well, let's get to it. So, some of the characteristics of acids and bases are that they're both considered to be electrolytes. Remember, electrolytes is just a fancy word for saying a salt. So, all it is something that can break into ions. Acids and bases both are able to do this. Acids tend to have a sour taste, while bases tend to have a bitter taste. Acids turn litmus paper red, and bases turn litmus paper blue. That's just like a quick way to indicate whether it's an acid or a base. Acids react with metals to form hydrogen gas. We actually saw this in our last unit when we were talking about redox. And bases feel slippery. They're kind of like a slimy feeling to them. Acids include vinegar, milk, soda, anything citrusy. And bases include ammonia, lye, Drano, antacid, baking soda, bleach, as I just said. So, models that explain the nature of acids and bases, we have our first definition, which is the Arrhenius theory, and it's a way to describe how acids and bases behave. So acids are compounds that yield H+ ions in aqueous solutions. So here you have, for example, hydrochloric acid. Again, this is an electrolyte, so it's a salt. You have, even though they're both nonmetals, they have a difference in electronegativity between the two that is greater than 1.7. So they're going to split into ions in the glass of water. And when they do so, the key thing based on Arrhenius' theory is that you get protons, these H+ ions coming off of your hydrochloric acid. So as long as whatever you have dissolves in water and gives up an H+ ion, that means you have an acid. That is called an Arrhenius acid. Let's take a second to think about what it means to form an H+ in solution, an H+ ion. So here we have our hydrogen atom, and normally the hydrogen atom has, I draw my atom, I have 1 proton because its atomic number is 1, so I'm just going to put a little plus on the inside. And I have 1 electron from the electron configuration is also 1, so I'm just going to put a little E-. I guess I'll put a P for proton. So right now we have a neutral atom. Every atom, as is on the periodic table, is neutral. And hydrogen is also neutral because it has 1 positive proton and 1 negative electron. Now, when hydrogen bonds with fluorine or chlorine, like in the example if we look at HCl, chlorine is more electronegative. If you look down at chlorine on your reference table, oops, that's not the eraser. Chlorine is more electronegative, and it is right here. Has electronegativity of 3.2, while hydrogen only has an electronegativity of 2.2. So chlorine is going to steal hydrogen's electron. And when it does so, we're going to have, when you put hydrochloric acid into like a glass of water, here's our water, chlorine is going to be negative because it stole the negative electron off of hydrogen. So it went from neutral to negative because now it has an extra electron. And hydrogen, because it lost an electron, is going to be positive because it only has one proton in the nucleus and nothing negative around it anymore. So that's why it has the H+. So if you think about it for a second, because hydrogen lost its only electron, it can now be called a proton because it is literally just a proton. There are no neutrons because one atomic mass of 1 minus atomic number 1 gets us 0. And there's no electrons because it lost its only electron to chlorine. So I will go back and forth between referring to hydrogen ion as an ion and as a proton, but I mean the same thing. I'm just talking about H+. But because it's just a proton in solution, it has a really hard time staying as a proton and staying stable. So what it likes to do is it likes to bond to the water molecules that are in solution. So here I have my water, oxygen, and I have my 2 hydrogens. And so this proton is just going to go and attach itself like that right onto the water molecule. When it does so, and there's still an electron pair here, when it does so, now the water has a positive charge and an extra proton because it just assumed the H and its plus. So when we look back at a reaction, like right here, we see that when hydrochloric acid is in water, it gives the proton, the H, onto the water molecule. So now you form H3O plus and chlorine minus, because again, the chlorine is now just by itself. It's just, this just literally switched and went on to here, and now chlorine's all alone. Again, the water is now positive because it has accepted H+, the hydrogen, and its positive charge. Arrhenius bases are compounds that yield hydroxide ions in aqueous solution. So we know acids yield protons or H+ ions in solutions. Bases, however, yield OH-. And that is also called hydroxide. So just like the hydrogen ion has 2 names, I call it a proton, or I call it a hydrogen ion. It can actually also be called hydronium ion because it's technically bonded to the water. The base has multiple names too. It is called hydroxide, or you can say the OH- ion. And the way it's formed is you have your sodium hydroxide. The OH is a polyatomic ion, so it's going to stay together. The sodium is just going to separate from the OH. So here we have our NaOH, and that yields sodium ions and hydroxide minus ions. So there we have it, folks. You have your introduction to acid-base chemistry, where you have an acid, you have an acid if you have hydronium ions or H+ ions in solution, and you have a base if you have hydroxide OH- ions in solution.